and I'm going to show you how to construct a translation. In this example, the vector is detached from the line segment. So the first step is to measure your vector kj. This vector is telling you how far each of your points are going to translate. It is also showing us which direction the points will translate. So up and to the left. So now I'm going to copy this vector off of point B. And I'm also going to copy this vector off of point A. Point B and point A should translate the same amount in the same direction. So this means B prime should end up along this arc, and A prime should end up along this arc. Now I need to figure out where point B prime will end up. And I'm going to start with point B and B prime because it's the closest point to my vector. So choose the closest point to your vector, and you're going to measure from B to one end of the vector. Now, translate down your vector, stop at point J, and you should make a mark. This mark should intersect your first arc, and right where their intersection, I call it X marks the spot. This is B prime. Now I'm going to measure my line segment. Since a translation is a rigid motion, line segment AB should be congruent to A prime, B prime. So how long is line segment AB? A prime, B prime should be the same length because translations preserve distance. They are rigid motions. So move your compass to B prime, X marks the spot, A prime. Lastly, you should always use your straight edge at the end to draw the new image. So we got a couple of things going on here. This is my pre-image. This is my image after the translation. Notice how both points moved to the left and up a little bit because that's the direction and the length that my vector is going in. If you want to, you can even draw in the vectors. The vectors that you're drawing should match the vector that's on your page. Okay. So hopefully this is helpful to you when you go to construct your homework questions or when you're looking back to study for this unit. Thanks.